Hello everyone. Today we're going to talk about interior angles of polygons. Now a polygon is a closed plane figure. Now closed, that means it's all connected. Plane figure just means it's two-dimensional and made up of three or more line segments that intersect only at their endpoints. So here on the left we have three examples. Those are closed plane figures. They're flat. All of the outsides connect. It's not open. And on the other side, well, we have not polygons. So the first thing you should notice is there's some curves. Curves are not line segments. They're curves. Therefore, not a polygon. And that last figure looks like an hourglass. Well, hourglasses crisscross. They have an extra intersection. So this is not a polygon. This would actually be two separate polygons, two triangles connected to each other. Now, what we need to know for today is how we can use what we know about polygons to find missing angles. So when we look, we will notice that I've got two polygons right here in front of us, number 1 and number 2. Well, number 1, the first thing I'm going to do is figure out, well, how many sides is this so I know what it is. And there's 1, 2, 3, 4, 5 sides. Well, 5 sides, if you remember, that's a pentagon. We have 5 sides. Now, in order to figure out the interior sum, now interior sum means if I add all of the interior angles together. Now, I bet you're wondering, how many angles are there inside? Well, number them. 1, 2, 3, 4, 5. So however many sides we have is exactly how many interior angles we have. But the theorem that we're working with today says if we add all those up, I need to know how much it could be. What is that number? And we do that by figuring out how many triangles, yeah, I said that, how many triangles are inside of this pentagon. So what I'm going to do is I'm going to change colors here real quick. I'm going to start here, and you just got to pick one of your vertices. And I'm going to draw out to every single vertices. So if I look here, I don't need to draw that one, right? Because that line's already there. But I do need to go from here all the way over to here. And I'm going to go back to the exact same point. We're going around. And I'm going to draw all the way over to here. Now I don't need to draw this line because it's already been drawn for me. But that's 1 triangle, 2 triangles, 3 triangles. This is worth 180 degrees. We know that about triangles. This is worth 180 degrees because we know that about triangles. And this is worth 180 degrees. So that tells me that I could take 180 degrees times 3, which is 540. And that is what the inside angles, when I put them all together, when I sum them or add them, will always equal 540 for a pentagon. Now we're going to try the same thing over here on number 2. So number 2, we look here. I wonder how many sides and angles we have. We have 1, 2, 3, 4, 5, 6, 7, 8. 8 sides. So we have an octagon. Well, I'm going to go ahead and turn this into triangles. And it doesn't matter where I start. I'm just going to start here. Here's the line that's already been made for me. But I'm going to go ahead and draw a line to here. I'm going to draw a line to here. I'm going to draw a line down to here. Another line here. And I've got one more to draw because that last one's already been drawn for me. Well, obviously these aren't very straight lines, but you can get the idea. 1 triangle, 2 triangles, 3 triangles, 4 triangles, 5 triangles, 6 triangles. So 180 triangles, right? Times 6. Well, 180 times 6 is 1080. So that means if I was to add up inside all of the angles on the interior of this octagon, they would add up to make 180. So let's just think of a quick rule. When I had 5 sides, I multiplied times 3. When I had 8 sides, I multiplied times 6. So that tells me that if I take the number of sides, which is also equal to the number of interior angles, subtract 2, That tells me how many triangles are inside. This is the triangles inside. Then I'm going to multiply that by 180. And that would be the sum of my interior angles. So let's put that to use. So here we have, well, I got this blue shape here, but let's figure out what it is. It looks like I have 1, 2, 3, 4 sides. So that would be a quadrilateral. Oh, page jump. So let's go ahead and 4 sides. So I'm going to take my 4 minus 2 and multiply that times 180. Well, 4 minus 2 is 2, and 2 times 180 is 360. And you might remember that a 4-sided quadrilateral always has an interior measure of 360. But that's not enough. All we do is know how much is inside. What they really want to know is x. Well, to find x, that means that all of these add up to equal 360. So it wouldn't matter where I started. I just need to put all my numbers together. So I have 25 plus 137. I'm going to go and put all the constants together. Plus 155 plus x. All of this adds up to make 360. So I'm going to go and put those numbers. 137, 155, and 25. What was that again? 137 plus 155 plus 25 equals 317. So that means that 317 plus x equals 360. Solving for x, so I'm going to subtract the 317. And x is going to equal 360 minus 317, which is 43. Okay, let's take a look at another one. Oh, I have a little stranger looking polygon here. I'm just going to figure out how many sides there are first. 1, 2, 3, 4, 5, 6. So that's a hexagon. So again, we take it the number of sides minus 2. That tells me how many triangles will fit inside. And then I'm going to multiply that times 180. So my interior sum is 130. No, my interior sum is 720. Getting ahead of myself here, 720. Now I need to set up my equation. So I noticed that my interior angles are x, 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 x. Well, that's 4 x's, so 4x. 90 and 90, well, that makes 180. And when I add all of that together, it should equal 720. Two-step equation. Let's subtract the 180. So 4x equals 540. Divide by 4. And each of the angles with an x are equal to 135. So this would be 135, 135, 135, 135. And we already knew that these were 90. And if I add all of those up, they're all going to add up to make 720. But they won't always give you a diagram. Sometimes they'll just give you a description. And it says, what is the measure of each angle in a regular? That word right there is really important, regular. Regular means that all of the angles and all of the sides are the same. And I want 7 sides, which is a heptagon. But I'm going to use the same formula. If I have 7 minus 2, that tells me how many triangles are inside. And I can multiply that times 180. So that would be 5 times 180, or 900. That's my interior sum measure. Now, we just said that that has 7 angles, and they're all the same. So that if I labeled them out, I would have x plus x plus x plus x plus x plus x plus x. Or I could simply say 7x equals 900. I would divide both sides by 7. And x would equal, well, 128 decimal 5714. And it's going to keep moving on. That's an irrational number. So what we're going to do here is we're just going to go to the nearest, let's say we'll go to the nearest 10th, because that's most frequently what they will ask for. Remember, the 10th means I only want one digit after the decimal, so x is going to equal 128 There's your decimal. The 5 rounds up because the 7 comes after it, so 128 6/10. So when we're looking at interior angles, you first have to figure out how much the interior is worth. You have to say, okay, I want the interior of this polygon, so I'm going to turn the polygon into triangles to figure out how much it's worth, and then I can use that total to figure out what's missing from the inside.